Okay, welcome to lesson 3. Today we're going to look at finding the coefficients of a polynomial. It's quite a common exam question where they replace one of the numbers in front of one of the terms with a letter. And you just have to use your knowledge to solve that. So we're going to start off with example number 1. If x plus 3 is a factor of 2x to the power 4 plus 6x cubed plus px squared plus 4x minus 15, find the value of p. So x plus 3 is a factor, that's the first piece of information we're going to use. So x plus 3 equals 0, take the 3 to the other side, and then that is what we stick through our synthetic division. So take the numbers, the coefficients in front of each term, so I'm going to take my 2, 6, p, 4, minus 15, and outside I'm going to put minus 3. Drop the 2 down, multiply by minus 3 to bring it up, add gives you 0, multiply to bring it up, p as 0 is just p, multiply to bring it up, so that's minus 3p, add to bring it down. Now when you do this, this is the only p term, so therefore that is minus 3p add 4, or you could write it as 4 minus 3p. Let's not overcomplicate things. Multiply to bring it up, so you're going to multiply each part by minus 3. So minus 3 times minus 3 is 9p. 4 times minus 3 is minus 12. And then you add to bring it down. So I've got my 9p, that's my only p term. Minus 15, add minus 12 is minus 27. Okay, now, because that is a factor, there should be no remainder. So this must equal 0. So I've got my 9p minus 27, and that must equal 0. And then all we've got to do to find the value of p is to solve that equation. So take 27 to the other side, and then divide by 9. And p equals 3. Okay, fairly straightforward example, I hope. Right, going on to example number 2. So when x to the power 4 minus 3x squared plus px minus 5 is divided by x plus 5, this time you get a remainder of 45. Calculate p. So this time it's not a factor, it's not a root. This time when I divide it by that, I'm getting a remainder of 45. Okay, so same process really. Start off with x plus 5 equals 0, take the 5 to the other side, so x equals minus 5, and then that is what you put through your synthetic division. So I've got 1x to the power 4, I have 0x cubes, can't leave that out. I've got minus 3x squareds, I've got p, I'll leave a bit more room, and then I've got minus 5. Alright, we're going to do the same process as normal, so you're going to drop the 1 down, multiply to bring it up, drop the 5, minus 5 down, multiply to bring it up to get 25, add to bring it down, multiply to bring it up, and add to bring it down, so minus 110, add p. Don't just put the p on the 110. Multiply to bring it up, so multiply each bit by minus 5, so I get 550 minus 5p, and then add to bring it down. So 550 add minus 5 is 545. That is my only p term, so I'm going to write that in there. Now, unlike last time, this is not a factor, this is not a root, therefore this does not equal 0. So therefore we are told the remainder is 45. So this expression here must equal 45. So I've got 545 minus 5p equals 45. Alright, all you're going to do is you're going to solve that now. So what you're going to do is you're going to take the 5p to the other side, or that's what I would do. You can do whatever way you want to do it. Take the 45 back to this side, tidy it up, and then divide by 5. So you get p equals 100. Alright, so example number 3, you've got a cubic function in the form of f of x equals to x cubed minus 2x squared plus ax plus b. And what they're saying is if it's divided by x plus 1, it gives a remainder of 8. And when f of x equals 0, so whenever the function equals 0, x equals 3 is a root. Okay, so 2 bits of information we're going to use there. And what we're going to do is we're going to find values of a and b in part A, then we're going to factorize fully part B. Okay, so let's take the first piece of information. We're told that when we divide by x plus 1, we get a remainder of 8. So let's have a look at that. Let's go x plus 1 equals 0, so x equals minus 1, and then you're going to use your synthetic division and see what we produce. So let's put minus 1, and then we're going to have 1x cubed minus 2x squareds, a x's and b. Alright, so we've got 2 letters to find this time, but let's see what we produce. Drop the 1 down, multiply by minus 1 to bring it up, add to bring it down, multiply to bring it up, so I get normal 3, add to bring it down, so I get a plus 3, multiply to bring it up, so I get minus a minus 3, add to bring it down, and what I'm going to do is I'm going to write the letters first. So I've got minus a plus b minus 3. And I'm told that when I divide by x plus 1, I get a remainder of 8. So this expression here, I'm going to make equal to 8. Okay, I'm also told that x equals 3 is a root. So if x equals 3 is a root, that means I can do the synthetic division again. And see what I produce. So I'll drop the 1 down, times by 3 to bring it up, add gives you 1, times by 3 to bring it up, add to bring it down, times by 3 to bring it up, so I get 3a plus 9, add to bring it down. I'll do the same as before, I'll bring the letters to the front. So I've got 3a, add b, add 9. And this time I'm told that when x equals 3 is a root, therefore if that is a root, there should be no remainder at all. And now I can make this expression equal to 0. So what I have here is I have 2 equations. With 2 unknown values. So all you're going to do is simultaneous equations. So we're just going to solve that doing your simultaneous equations however you choose to do them. Now, well aware some teachers have taught different methods, etc., etc. So what I would do initially is simplify the coefficients. So I would rewrite the first one as minus a plus b equals, and then I would take the minus 3 over to get 11, and then I would take the 9 over, so I've got 3a plus b equals to minus 9. Alright, and then you do your simultaneous equations however you choose to do them. We're not here to go over that particularly. The b's are the same, so if I subtract top line from bottom line, I'd do minus a take away 3a is minus 4a. 11 minus minus 9 is 20. b take away b disappears. Divide by minus 4, you get minus 5 as your answer for a. If you then go and substitute that, a equals minus 5 into one of the formulas, you'll get the answer for b. So let's go for minus a plus b equals 11, and a is minus 5, so I've got minus 5 plus b equals 11. So minus minus 5 is just 5, add b equals 11, so b equals 6. Alright, so I've got values for a, I've got a value for b. Okay, so to do part b, you've just worked out that a is minus 5, b is equal to 6. So therefore, there's two ways to do this. What you could do is you could substitute that into your function, replacing the a with -5 and your b with 6. And then you can do your synthetic division again. You were told in the original question that x equals 3 is a root, so you're just essentially repeating the synthetic division you did before, okay, where you had 1 minus 2 minus 5 and 6. Drop the 1 down, times to bring it up, add, times to bring it up, minus 2, times to bring it up, 0, and therefore, because x equals 3 is a root, x minus 3 is a factor. That's your first bracket. You get your second bracket from your quotient here, where you've got x squared plus x minus 2, and then that is x minus 3, x plus 2, x minus 1 for the answer. Alternatively, you don't have to do all this bit. What you did on the previous page was you did your synthetic division. If I write it out again, just to show you. We got 3, 3, 3, a plus 9, and you had 1, 1, a plus 3. Okay, now instead of doing all this again, you could go back to what you had before, and you knew you were going to use that one because that was the root. You know a is equal to -5. So you could have just done -5 add 3 equals -2, which would then skipped to that stage. You wouldn't need to do this all again, and then you could just repeat the next stage down here. All right, I hope that makes sense. Task 3 will be uploaded shortly. Thank you very much.